Hello, and welcome to Mix and Nick's Good Driving Tips. I'm Mick.
And I'm Nick, and today we'll be going over several different tips and tricks when it comes to driving. I'm a physics professor.
And I'm a professional rally car driver, so you know this is the real deal.
Today we'll be looking at how Newton's 3 laws of motion help us drive safely.
First off, to understand Newton's 3 laws, we must learn about inertia.
Inertia is the property of an object that resists changes in its motion. This means objects resist changing direction and speed if no force is acting upon them. To drive safely, we should keep in mind that objects inside the car can be just as dangerous as objects outside the car. Newton's first law explains the motion of the car as well as objects inside the car. His law states that a body will continue to move at the same speed in the same direction for as long as there are no unbalanced forces acting on it. For example,
Milton is driving at an average speed of 100 kilometers an hour with his coffee in hand. He sees a stale green in the distance and floors it to try to make the light. His coffee shifts to the back of his cup, but only little. The light turns yellow, but he keeps accelerating. He is so close when suddenly the light turns red. Milton slams on the brakes. His coffee flies out of his hand, hits the steering wheel, and the steaming hot coffee lands on his crotch. Don't speed up to make stale greens, lest ye suffer thy same fate of Milton.
in this situation, the coffee has a velocity of 100 kilometers an hour forwards. When Milton hits the brakes, the coffee continues to have a forward velocity while the car is accelerating negatively. Therefore, the car is slowing down, but the coffee is still going 100 kilometers an hour forwards. Next up, we have Newton's second law. His second law states that unbalanced forces equal acceleration. For example,
Milton is driving home from the hospital going the speed limit, 50 kilometers an hour. Billy is in a car behind him with a following distance of 1 second. Suddenly, a deer jumps in front of Milton's car. He stops abruptly, but Billy is too close behind him to stop in time, and therefore hits Milton.
following distance should be at least 2 seconds in good weather conditions. Here, Billy doesn't have enough time to change his acceleration to 0. His applied force is larger than his force of friction, and he doesn't have enough time to balance the forces, so he hits the car in front of him. Last but not least, we have Newton's third law. His third law states that every action has an equal and opposite reaction. This is also seen in driving in collisions with other cars. For example,
Buddy is returning from a Christmas party. He's had a few drinks. He doesn't even realize he's on the wrong side of the road. Unfortunately, Milton is on the roads once again. His headlights are burnt out, and he's on his way to get them fixed. Both cars are relatively the same mass, and all of a sudden, Milton sees headlights straight in front of him. But it's too late. What a day for poor old Milton.
here the cars repel each other because they have the same mass and speed, so their action of hitting each other would have an equal and opposite reaction, pushing them both the same amount. However, they're lucky they didn't hit a semi-truck. Semis have a much larger mass, so it would push the small cars backwards and crush them.